Okay, we're going to have some lessons today on predicting products. And so no matter what reaction you're getting, you're going to follow these same 3 general steps. So your first thing that you need to decide is, what kind of reaction is this? Is it a synthesis reaction? Is it a decomposition reaction? Is it a single displacement, a double displacement, or combustion? And depending on the reactants that you're given, there's some different clues that you're going to see that's going to help you decide what kind of reaction you're dealing with. Once you've decided the kind of reaction that you have, then you're going to move on to predict your products and figure out what you are making. You are going to need your periodic table handy for this. For some of them, you're going to need your common ions sheet. And then you have a new sheet that we're going to be using for single displacement reactions that's going to require something called an activity series. And we'll get to that in the single displacement video. And then your final step, always, 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 now that you know how to balance, everything should get balanced. And so this first reaction that you're going to see here, the clue, or the thing that's going to help you decide what kind of reaction, is that both of your starting substances are elements. So they're not combined with anything else. And so anytime you see an element plus an element, plus is a little close to where I wrote element there. So element plus element, that will always tell you you're dealing with a synthesis reaction. So you're combining 2 simple things and you're making something that's more complicated. When you predict products, so your steps for predicting are pretty simple here. Because they're lonely, the only thing that they can do is combine. And when we give these to you, the ones that we're going to give you are going to be ionic compounds that you're making. And when you make an ionic compound, all you have to do is combine your metal with a nonmetal. And when you do that, you want to make sure you are crossing your charges. And so cesium and sulfur is what we're combining. I'm going to show my crossing of my charges over here on the right. But cesium, if you look on your periodic table, it is an alkali metal, which means it's in that first group, has a +1 charge. Sulfur is a chalcogen. It's over in oxygen's group. We have that labeled with a -2 charge. If you crisscross those, you're going to end up making CS2S. And then your last step is going to be to balance. And so I'm going to show you taking inventory here. We have cesium atoms, we have sulfur atoms. Over here, we have 1 cesium because there's no subscript. On the reactant side, we also have 1 sulfur. Over here on the product side, we have 2 cesiums and 1 sulfur. So as of right now, the only thing that needs to get fixed in order to conserve mass is the cesium atoms. And so if we want 2 cesium atoms over here, you cannot add a subscript. It has to be a coefficient. We're just going to throw a big 2 in the front here, which is going to take that 1, you're going to multiply it by 2, and that's going to give you a final number of a 2. And so cesiums match, sulfurs match, you're all balanced, and you've hit all 3 steps.